All right, AP Stat students, it is time for the random variables unit test. This is probably the most difficult of the unit tests, but it's also probably what I would most likely expect to be on a free response question. So definitely try to make sense of this unit. Super important. It kind of is a combination of a lot of previous units combined. So without further ado, let's get started. All right, we take a minute to read this. All right, so the idea about this question is that Casey is guessing on the last 10 questions of her test. Each one has 5 possible choices. Now that means that each of her choices has a 1 in 5 chance of being correct. So 1 in 5 being correct. And the question is, what are the odds that she gets 2 correct? And so the thing about that is it's kind of a little bit tricky. So this is the odds of getting any question correct, and we want that to happen twice. So we actually raise it to the second power, times not getting it correct, which would be 4 out of 5 for 8 questions. Now the idea though is it's actually possible to get 2 questions right in a lot of different ways. It could be the first 2 are correct and the next 8 are wrong. It could be the first is correct and the last correct and the 8 in between are wrong. And there's a bunch of different ways to kind of quantify that. But one way to write that mathematically is that we write it as 10 choose 2. If you see it written like this without any like comma or fraction or something else, that means 10 choose 2. In other words, out of the 10 options, we only want it to happen twice. What do we want to happen? Getting the correct answer twice and an incorrect answer 8 times. So the correct way we would format that is right here. And also, just so you know, this is an example of binomial probability, and we can actually see that formula, where is it, right here on the reference sheet. So 10 questions, 2 correct, the probability of 2 correct to the power of 2 correct, 1 minus the probability of getting 1 correct, to 10 minus 2 correct. There we go. All right, for the next question, 7% of US citizens have US adults have O negative blood type. Which of the following choices are binomial random variables? So one key condition of binomial is that you have a fixed number of trials. So in other words, it's definitely B or C. A would be an example of geometric. And let's see here. So if we have a fixed number of trials, the probability doesn't change in between. I think it would actually be B and C, but I'm reading kind of fast. But that is correct. And so I'll kind of stop for a second here. You can pause the video and read why that is. But binomial is fixed number of trials. The probability between each trial doesn't really change. In other words, there's so many US adults that choosing 50 won't really change the probability of choosing one and then another and then another. There's so many adults that just choosing 50 barely scratches the surface, so it's almost as if each time you choose someone, you haven't really changed any probabilities. All right, up next, let me read this real quick. All right, so this is again an example of binomial. And if you read this question, it's because he's definitely choosing 6 boxes. In other words, the number of trials is fixed, and he has a 1 in 4 chance of winning. So the amount of trials is fixed, and each time he opens a box, he knows he has a 1 in 4 shot. So the question is, what is the probability he wins exactly 2 prizes? And so again, that comes down to, well, 6 boxes, choose 2 successes, and then let's see here. Well, the odds of winning twice is getting 1 out of 4 to the second power times not getting 1 out of 4, which would be 3/4, 4 times. So the probability of winning twice, exponent, times the probability of not winning 4 times. And that could happen in any combination of ways. Again, the idea is he could win the first time and the second time and not win the last 4, or he could win the first time, not win the second time, win the third time, and you can kind of see that the options start to get kind of complicated. Now, how do we figure this out exactly? I'm going to use my calculator here. So I'm going to go to 6, and then I'm going to press math, number, NCR combination. 6, choose 2. So another way of writing that first kind of weird parentheses there, times 1 out of 4 is 0.25, squared, 2 being 1, times not being 1, 4 times. We end up getting this. Rounded to the 100th is 0.2, actually it's 0.30, because it rounds up. All right. I guess I should say also really quick, you could go to stat, and actually you could go to second distribution. Since you recognize this binomial, or if you did, we only want one particular case, in other words PDF. So there were 6 trials. The probability of winning was 0.25, we wanted twice, and you can see we get the same answer a lot quicker. Alright, up next we're supposed to calculate the mean of f given this kind of box plot here. And so the x is the number of repairs randomly chosen. Now this is a little bit misleading because if we wanted the profit, we would multiply the profit times the probability, but since we just want the number of repairs, it's going to be 0 times 0.9 plus 0.07 times 1 plus 0.02 times 2 plus 0.01 times 3. In other words, what we're doing in this problem is, let me pull it up here, this question right here. The mean of x is simply each value, the number of repairs, times the probability of that repair. So 0 times 0.9 plus, that's what that big E means, it means add all the options, 1 times 0.07 plus 2 times 0.02 plus 3 times 0.01. Let me work that out real quick. Oh, and I dropped my reference sheet. 0 times 0.09 is just 0, so also 1 times 0.07 is just 0.07, so now I'm going to start actually calculating. Plus 0.02 times 2 plus 0.01, sorry I wrote that kind of sloppy, times 3, and I get 0.14. Alright, and next, kind of same idea, find the missing probability. Now the idea is all probability has to add to 1, so let me add up all these prior values, 0.15 plus 0.27 plus 0.35, sorry, 0.27 plus 0.35 plus 0.15 plus 0.04 plus 0.01. That equals 0.97, so the missing value must be 0.03. That way I would add up to 100% or 1. Alright, up next, let's see here. Essentially the question is find the probability that it takes Zach 2 or fewer throws to score his first ringer. Now this, since it says to score his first, this is an example of geometric. Geometric probability says there aren't a fixed number of trials and you're just trying to calculate when the first success or first ringer happens. You can kind of read this case and figure out what's going on here. But that's going to be a calculator question, second distribution, and we're going to go to geometric CDF because this is essentially second or fewer. So geometric CDF. And we'll calculate this by hand if you don't have a calculator, but the odds of getting a ringer is 0.4, and we want this to happen at 2 or less times. And if it says 2 or less, we need to include 2. If it said less than 2, we would only need to plug in 1. Remember, CDF only goes from your value down. So we get this answer, 0.64. Now, I want to show you how you get that without a calculator. And so here's how this works itself out. If it happens on the second time, it means it didn't happen the first time, which happens 0.6% of the time. And let's see here, it takes 2 or fewer. And so that means it had to happen on its second time. So we have to calculate that. Plus, what if it did happen its first time? Well, then that happens 0.4% of the time. And really, that's about it. So we can only calculate those 2. And if you multiply this out, this will be 0.24 plus 0.4, that gets you the 0.64. And maybe we'll pause here.